All right, I think I'm recording. We'll see. Before I begin, very important, everybody turned in their quest, right? Okay, perfect. What's up? Yours in the learning lab. Alrighty. So we are meeting on page 6 because we're going to do some of those problems that I was talking about before. When you integrate, you have to tack on a plus c because you're basically finding the family of functions that that integral came from, right? So if we tack on a plus c, but now we are given something called the initial conditions, we can find c. We can find c. I'll show you how it works, okay? So if I have the derivative, and I'm given the derivative, and I need to get back to the original, I can integrate the derivative. Don't forget your dx. You lose points if you forget your dx. Your dx is the differential. When we go over what a definite integral is, it becomes more obvious what the dx is, but it's pretty much just if you were to approximate the area under the curve, it would be the width of the rectangles that you could fit into that area. We're going to go over it in a couple of days, okay? But for now, you can just think about it as, oh, this is the, like, I will be integrating with respect to x, okay? All right, so let's use our new rule, right? We got 3x squared. We're going to add 1, then divide by the new power. And you could work piece by piece. You could split up an integral with pluses and minuses, which is cool. So now if I have 2x to the first power and then I add 1 more, I now have to the second power and I divide by the new power and I add my c. This is the original. So let's clean it up a little bit, right? These cancel and I have x to the third plus these cancel, x squared plus c. So now if I wanted to figure out what the original function passes to, what particular family does this guy belong to, I could solve for c by using the initial condition that was given. He's like a clue, right? So this is a point on the initial graph, right? Just look and be like, oh, he's on f, and I'm integrating the derivative. I'm trying to find f, so this is what's going to find me my plus c. So this is an x, this is a y, and I'm going to plug that stuff in to find Yup, c is -7. So put it all together. He has his family. He has his home. That was the original function. Okay. Not too bad, right? Hey, what derivative rule are you kind of doing the inverse of? The opposite of? The power rule. Good job. All right, we're on to the next one here. It says find f of x. So we're going back to the original. Given that f double prime of x equals 2x, and the points 1, 0, and 0, 5 lie on f of x. So I'm given the second derivative. Any thoughts on how we're going to get back up to that original? Double integral, but it's kind of more of like integrate twice because a double integral is going to be haunting you later on in your math career. So we're going to think about it as integrating twice, okay? So first, we're going to integrate that second derivative to get the what? First derivative, right? So let's label our stuff so we don't get lost. All right, so I'm finding the first derivative. I'm integrating the second derivative. And I'm going to be getting something that looks like this. 2x squared divided by 2 plus c. However, it looks like I'm going to be integrating twice. So how many Carls am I going to have? 2. What's better than 1 Carl? 2. So let's label them. This is the first Carl. This is the Carl from whence all other Carls came. Oh no. The derivative is x squared plus c naught. Okay, that looks like a 6. Sorry. Okay, let's think. Which clue is going to make something disappear? Nothing yet, right? We're still at the derivative. We got to get back up to the original, right? So I'm going to integrate one more time. This is going to get me to the original. And I got x squared plus c naught dx. Okay, so I'm going to get back to my original by x to the third divided by 3. Is that okay if I start doing it a little faster? You saw that I added 1 and then divided by the new power. All right, and then what's going to happen to the c naught? What does he get now? Carl has given birth to a brand new baby.
He's going
X. Good job. And there is now a second Carl. What should we name him? Carl Jr. Let's call him C1 for abbreviation for Irving. So I now have my original and I have two clues. Which clue is going to make something disappear when I sub it in? Yeah, right? Because when I put that 0 in for X, original Carl is going to disappear, right? Okay, so I've got, this is going to be my first clue. And I would be like, okay, I got 5 equals 0 cubed divided by 3 plus C0 times 0 plus C1. Oh, actually, it's just what? C1 is what? 5. Okay, cool. So what do I have right now? Let's put it all back in, right? I've got, bless you, x cubed divided by 3 plus, I'm just going to put the x in front of the C0 because it just makes it like a little easier to figure out what's going on. We can leave it like that, it's fine. Okay, and then plus 5. All right, what should we do now? Do the second clue, right? Where is it? Second clue. This is the second clue. All right, so I got 0 equals 1 to the third over 3 plus C0 times 1 plus 5. 0 equals 1/3 plus C0 plus 5. All right, let's combine the 5 and the 1/3. So if I had to put them in terms of threes, I would have 15 over 3 plus 1 more gives me 16 over 3, right? So I've got 0 equals 16 over 3 plus C0. I'm going to move the 16 over 3 over. And I now have C0 is negative 16 over 3. All right, put it all together. What do we have? F of x is equal to x cubed over 3 plus, what was C0? C0 is actually a minus 16 over 3, x plus 5. Yay, and we now know exactly what that particular original function looked like because we had 2 clues that we needed him to pass through. You're going to do stuff like this all the time in Calc 2 or BC Calc because you're going to be doing it with slope fields and it'll be really cool. You can find you guys are glazing over. Okay, this will come back. You will do more with this. But let's go to the next one. Okay. A population of alien bacteria is growing on the Spirit rover at a rate of, okay, so I wanted to give you this one because if you're given a rate, what do you think that corresponds to in terms of like, yeah, it's like the derivative, right? Or yeah, sure, the velocity, he's a rate, right? So it all kind of lumped together and you're like, oh, so you've been given the derivative and now let's see what I have to do with it. Where t is time and days since the rover landed. If the initial bacteria population was 100, hey, what's that? That's a clue to help me satisfy the original conditions or the initial conditions, right? So when t equals 0, the population was 100. So we would say p of 0 equals 100. Our original that we're trying to find is going to be p of t. And the way we're going to get there is by integrating r of t. Are we good with the plan? You ready to go? Yeah. Okay. So let's integrate e. It's such a tiny baby t. E to the t over 4. Now, let's think, right? Wouldn't it be so much easier to envision what was going on if we popped that 4 out in front so we had 1/4 as a coefficient, right? Okay, let's rewrite it like that so that we were like making a plan to make our lives easier. Okay. Okay. And then minus 2t squared dt. Okay, the rest is fine. So we just talked about how if we integrate e to the t, we land with e to the t, right? So if we take that 1/4 and leave them out front as a coefficient, now it's like way easier to think about because we're like, oh, we just leave the 1/4 out front. You just ignore it. Just like Declan. And then let's do the other one. Minus 2t squared, ooh, add 1 and divide by the new power, plus c. what did we just find? We found P of t, right? I apologize for the numbers on this one. You know how it goes. So I've got P of t is equal to, let's clean it up, 1/4 e to the t minus 2/3. I took that division by 3 and just kind of moved it out front so it's a coefficient. This is going to be what we're usually going to want to do. It's easier to deal with a coefficient than a denominator, so to speak. So now I got t to the 3rd plus c. All right, what's my next move here? Give me the move. Yes, I'm going to have 100 for my P of t, and then I'm going to put in a 0 everywhere I see a t. So I've got 100 equals 1/4 e to the 0. Thank you. Thank you. So many people were putting 0 on the test, the Unit 8 test. It's like, oh my gosh. All right, so what's going to happen now? I got 100 equals 1/4. This drops off plus c. Minus 1/4, minus 1/4. I'm really sorry. How can we rewrite 100 as a smart version that can be combined with 1/4? Sorry. So c is what? 399 over 4. Yeah, I know. I'm really sorry. So the original P of t is 1/4. Let's go back. E to the t minus 2/3 t cubed plus 399 over 4.
They always have like weird numbers like that, or are they like nicer?
It depends.
Okay. It's like,
Sometimes they are, sometimes they're not. I made that one up, so it was bad. Yeah, sorry. That's okay, it's good. You got to deal with fractions a lot when you integrate, because you always end up with like fractions because you're dividing by the new power, so you got to get those fraction skills tight and right, especially with definite integrals. All right, I wanted to go over a few tricky ones on your homework really quick,
wait, the homework includes page 9.
just to talk about the methods you might want to use. 7, 8, no. Did I write 9 on the board?
Just 7 and 8.
Just 7, 8.
Okay, I just want to make sure.
Okay, the first one's easy, second one's easy, third one is easy. Let's just double check right here. What is this guy? When I integrate 1 over x, ln of the absolute value of x. So just maybe give yourself a little star there. Double check that one. Okay, what if you have something that looks like this? So in integrals, right now, you do not know the equivalent of a product rule. So if you see a product of two functions and they expect you to take the integral of it, you got to combine the powers of x and get like one singular power of x, because you don't learn about the like product rule of integrals until next year when you do integration by parts. So if you like see this and you're like, oh, it's a product rule, I need to do some other algebra to get where I need to go, right? So you could just rewrite this one as x to the first times x to the 1/2. Now he becomes x to the 2 over 2 times x to the 1/2. We now have x to the 3/2. Okay, so like that's how you're going to get started with that one. Remember, we haven't taken the integral yet. We could keep going with this one, that's fine. Minus 2 over x. Let's think about that guy, right? Would he be more obvious like this? Is it more obvious what to do if we do that? Maybe, right? So if I integrated this guy, right, I now have x to the 3/2, I add 1, and divide by the new power. Division by 5 over 2 is the same thing as multiplication by 2/5. So this might help save some of the mental load, right? I now have a 2/5 like this, right? Minus 2 times, this guy's the ln of the absolute value of x, plus c. All right, so now you got 2/5 x to the 5 over 2 minus 2 ln of the absolute value of x plus c. Okay, so maybe you can make yourself a note here, right? Maybe like no product rule. If you think you have a product rule, you got to combine the powers.
How come you do absolute value of x? You know?
Because think about the argument of an ln. It's got to be positive. Okay, what about this one? He's the same idea, right? What should you do? Yeah, you're going to get like a singular power down here, and then how do you bring it back up? So we actually just did this. What did that guy end up being? x to the 3 halves, right? But he's in the denominator, so what is he going to turn into? X to the negative 3 halves, right? And then this one is plus 4 times 1 over x dx. Maybe that'll help you get started, okay? Let me see if there's any other ones that were like hard to do. Maybe on 8, let's look at 8, right? This thing right here. What is this algebraically equivalent to? That, right? Does that help you? Yeah. You're just looking for the rewrite, man. All right, so you would keep going with that one. The next one is, these are just piece by piece, no problemo. What are you going to have to do here? This looks like a product rule. That tells me I need to combine the powers, right? Okay, this guy. What about this? Let's look at question 13. Integration methods, right? X times x minus 1. I think that we should multiply this out, right? He looks like a product rule, and it's not going to work, right? So I've got x squared minus 1 x over 3 plus cosine x dx. Okay. So if I have x squared minus x and it's all over 3, can't I decompose that in a way where it's like this? Is that totally fine? Yeah, now I'm piece by piece, right? Oh, now I split that 1/3 out front. 1/3 x squared minus 1/3 x plus cosine x dx. Now it's just easy money, piece by piece. All right. Let's talk about this one. Any thoughts on this guy? Split it up. It's like fraction decomposition, right? So I've got 2x over the square root of x minus 1 over the square root of x dx. So what am I going to want to do with these? Remember, you don't know a quotient rule either. The quotient rule is going to indicate that you probably have to do u substitution, but you'll learn that in a couple of days. I wouldn't split them up. I'd combine them, right? When you...
Oh, yeah, subtraction.
Yeah, so when you're dividing like bases, you subtract the exponents. So I'm now going to have 2x to the first minus x to the 1/2, right? And then what should you turn the other one into? X to the negative 1/2. Take note that we have not taken the integral yet, okay? You're just combining powers. So this would be 2 over 2 minus 1/2, so this one would end up being 1/2, right? That would be like the final power of him. The final power of this term. And then you can just go from there. Any other brain busters? The rest are just initial conditions. Right away, are you starting to see a pattern? If you've got denominators, what do you got to do? You got denominators, what do you got to do? You got to split it up, right? So I'm like, okay, let's get a singular power down here. We know that x squared times the square root of x ends up being what? X to the, yeah, I got x to the 4 halves times x to the 1/2. So that's going to be x to the 5 halves. All right, so I got x to the 5 halves down here. And if I'm splitting it up, right, I now have x squared over x to the 5 halves minus 4x over x to the 5 halves plus 10 over x to the 5 halves dx. This guy is going to be combined with him, right? So I've got 4 over 2 minus 5 over 2 gives me x to the negative 1/2, right? And then I've got x to the first, so that's 2 over 2 minus 5 over 2. That's going to give me 4x to the negative 3 halves. And then this guy's just going to come up and be a negative exponent. And now you can integrate. Can you guys find one more example where you would use this trick? Which one do you think you would use this trick on? One more sticks out to me. 23. Good job. You could just write partial fraction decomposition. Or just fraction you could just do fraction decomposition if you want. Frac decomp. Ew. Is that what? Is that illegal? What? All right. I think you're gonna be just fine. Let's do some GimKit. You guys want to do a GimKit? We got a little heated in set 7. I don't know. People at home, that was it. Bye. Have a great day.